This video is about setting up a DC blocking filter for the Sampling and Aliasing Lab. It corresponds to section 14.4 of the Applied Analog Electronics textbook. Okay, in that section I gave you a filter design. This one. The idea of this filter design is that the 10 microfarad capacitor there will block DC, and then the pair of resistors, which are identical to each other, will recenter the voltage at 1.65 volts. And the combination of the very large resistors and the large capacitor there give you a very large time constant, so that low frequency signals will still pass through this thing just fine until they get really low. So DC will be blocked, but low frequency signals like 1 hertz and 2 hertz are still going to go through with no problems. Okay, you're going to need to implement this filter, which is a fairly straightforward thing to do. Here's one of many ways to do that. I've got power and ground coming from the TCLC board and going to the red and blue long wires here. Then I have a pair of resistors here which both go to the same row. One is coming from the 3.3 volts, one's coming from the ground. You have to make sure that there's no way that the 3.3 volts and the ground can short each other here. I've got the long wires here both going to the same node, so if they contact each other, it doesn't matter, they're already connected. I have a capacitor here that goes over to another row, so that's now between row 40 and row 42 there. And I have some double-headed pins here. And those double-headed pins are so that I can connect the yellow wire now, not to A0 the way we were doing when we were directly connected, but over to one side of the capacitor, and the other side of the capacitor is connected to both of those resistors and via this brown wire over to A0. So now the signal is going through the capacitor, which blocks the DC but lets the AC through, and in fact lets some pretty low frequency AC through, and gets recentered at the 1.65 volts, the midpoint between 0 and the 3.3 volts. Okay, so let's go over and take a look at what's happening here. I've got this thing set up to be 2 hertz with 1.5 volt amplitude, 1.6 volt offset. So this one's already safe. It's between 0.1 and 3.1. It should be being recentered to be just a little bit higher. And let's take a look to see if it is. So we go over to Teradek, which was running before, and I'll just record. And it's looking like everything's working pretty well. The recentering, however, is going below 0. Let's stop that then. Why is it going below 0? Well, this signal here doesn't spend equal amount of time at all voltages. It only spends a little bit of time at the bottom voltage and a lot of time at the top voltage. And that means that the low-pass filter, the high-pass filter, when it's averaging the signal, is going to have this end lower than this end for the average to come out to being about the 1.65 volts we want. In fact, if we look over here, it's averaging 1.79 volts, more than 1.65 volts, even though it was going below 0. So we have to be a little bit careful here. Let's bring the amplitude down. Bring it down to 1 volt. Now, if it drifts a little bit, it's not such a big problem. So this is going to be 1.6 volts plus or minus 1 volt now. Clear the data. Let's start running this again and recording again. And now we can see that it's doing more what we expect. So we can stop this. There's a couple things that are a little different from before. One is that it seems to be drooping a little bit here on this flat spot. That's because that flat spot is low enough frequency that it's starting to be blocked a little bit by the DC blocking capacitor. And so this is starting to droop from the value you wanted it to be constant at. So, but it's not drooping very far. It's not a big problem. Notice that the average value here is still not 1.65 volts. It may be that my resistors aren't matched, or maybe something else going on here. I could try putting in a symmetric waveform to see if this is it asymmetry. So I can go here and say, instead of a ramp up at 50%, I could do sine at, I believe it's 100%. Not square wave, sine wave. There. Now that's a symmetric waveform, and we can check to see what its DC value is. So instead of a 2 Hz ramp up at 50%, this is now sine wave. And clear the data, record, and I forgot to run it. And now we can see we're getting something that's much closer to what we expected. It says 1.68 volts rather than 1.65 volts. But if we look over here, 3.305 volts, it's pretty close to the 3.3 volts we expected. So this is just a little higher than we expected. That may be because we have a little bit more waveforms at the top than at the bottom. We didn't get an exact integer number of cycles, perhaps. But it's looking pretty close to what we expect. So the filter is probably working at this point. We can test that by saying, well, wait a minute, if we set the offset here to 0 volts, now normally that would be dangerous because we'd be going negative, but the DC blocking capacitor should be blocking that, and it should be centered about the same way here. So we clear the data and start running this one and record. And we can see we're centered about the same place we were before. So the filter here is working. And this is now not 0 volts. It's 0 volts plus or minus 1 volt. And you can play around a little bit, make sure that your filter is working. You might want to check to see how low a frequency you can go down to before it stops working. Play around with it a little bit. Make careful records of what it is you're recording here, because if the filter's working, when you look at the output of the filter, you can't tell what the input DC offset was. That's being blocked. So you have to record it manually. Okay, so you want to create some sort of demo that shows that your filter is working. It does not have to be particularly fancy. This tutorial is not about filtering. Tutorial is about sampling and aliasing. So the DC blocking thing is just a little bit of a side note on, hey, if I couldn't do offsets in my function generator, how would I have handled that? Okay, like I said, this is more of a side note for the lab, so not worth spending much more time on.